the bonus question. And honestly, this is my favorite question in the entire test. I think it's a very fun question. It says find n so that the permutation n choose 4 is equal to the permutation of n plus 1 choose 3. So first I'm going to do is do my permutation equation. Again, remember permutation of n choose 4 is going to be my n factorial divided by my n minus 4 factorial. And then my permutation of n plus 1, choose 3 is going to be n plus 1 factorial divided by n plus 1 minus 3 factorial. So I'm going to go ahead and actually list out what this is going to look like. Again, n factorial, if you have like 5 factorial here, would be 5 times 4 times 3 times 2 times 1. And so this is going to be the same thing as n times n minus 1 times n minus 2 times n minus 3. And then it's going to be n minus 4, n minus 5, n minus 6, except for the fact that I have n minus 4 factorial on the bottom. So if I keep going any farther, like I have the n minus 4, which I'm running out of room here, I would then divide it by n minus 4, n minus 5, n minus 6. So the n minus 4 is actually going to cancel out. So n choose 4 is going to be n times n minus 1 times n minus 2 times n minus 3, and that's it. I have my 4 slots I'm choosing, and each one reduces by 1. Likewise on the bottom, first of all, n plus 1 minus 3, I'm just going to replace this as n minus 2 factorial. So that's gone. So same idea. I'm going to have n plus 1. If I take 1 away, I'm going to have n. And then n minus 1. And then again, if I have n minus 2 here, on the bottom, I'll have n minus 2. So these would cancel. I'm left with n plus 1 times n minus 1. So I want these two permutations to be equal. So I'm actually going to drop down here a little bit, expand my page, and just write them in a straight line with an equal sign. So in the top, you guys remember, I'll have n minus 1, n minus 2, and n minus 3 has to equal n plus 1 times n minus 1. The nice thing here is I can actually go ahead now and eliminate by dividing. If I divide both sides by n and n minus 1, that cancels, and on this side those two cancel. So I'm left with n minus 2 times n minus 3 is equal to n plus 1. FOIL here, I get n squared minus 5n plus 6 equals n plus 1. Yes, you know exactly where this is going. I'm going to subtract n and I'll subtract 1 from both sides. I'm left with n squared minus 6n plus 5 is equal to 0. I can use my zero product property, so I'm going to try to factor now the n squared minus 6n plus 5. So I need two numbers that multiply to 5, add to negative 6, which is going to be n minus 5 and n minus 1, which means either n equals 5 or n equals 1. The problem with n equals 1 is that if you have one person, you can't choose 4 slots because you do 1 times 0 times negative 1 times negative 2, which makes no sense for permutations. So that one's gone. You're left with n equals 5. So going back up to our original question, that's going to be it, n equals 5. So the two numbers we're actually going to choose are 5 and then 6. So permutation of 5 choose 4 is equal to the permutation of 6 choose 3.